Hi everyone. Before we add our last shape today, really two shapes, although they're pretty directly related, I thought we'd just take a second to do just a little review. So imagine if we were in class, this would be our smart problems. So I'm going to ask, let's read this one together, and then you could pause the video and give your answers and then see if you agree. So refer to the cone shown at the right. Determine if each statement is true or false. So I'm just going to look at this cone. He's kind of, he's going to hold his ice cream. So his vertex point is pointed down. I see that there is a radius of 7. I see that the height is the dotted line through to the center, which is 11. And to be perfectly honest, this 13 out here, is, as far as volume goes, is extraneous extra information. You could actually have found that just to do a blast from the past. You might see a right triangle there, and if you took a squared plus b squared, it would equal c squared. But enough about that. I have a height of 11 centimeters and a radius of 7. The first one is the approximate area of the base is 153.9 square centimeters. Area squarea. Think about that, guys. They're asking for area. Part B, the approximate volume of the cone is 886.5 cubic centimeters. And finally, part C, the volume of a cylinder that would have the same height and the same radius would be 3 times the volume of the cone, true or false. So those are all true and false. And number 13 is a pyramid, and they're asking for the volume of that. So I'm going to ask you to pause the video and see what you think about those. And then when you're ready to go, unpause the video and we'll see how you did. Okay, so the first one is asking for the area of the base. And the base of a cone, it's upside down right now, but it's a circle. So the area of the circle is pi r squared. So if we were to put that radius in, it would be pi r squared. And if you take 7 squared, it's 49. And 49 times pi will give you approximately, 153.9 square centimeters. That's area, just the area of the circle. Now we want to know about the volume of the cone. So the volume of the cone is going to be that same measurement times the height, and then take a third. So you'll see that pi 7 squared in there. That's the area of the base. Multiply it by the height. If you stopped there, you'd have a cylinder. But when you divide it by 3, you'll get the volume of the cone. And if you do that math, you'll get about 564.4 centimeters cubed, because we're now talking about volume. And since we were looking for 886, that particular part would be false. Finally, on number 29, the volume of a cylinder with the same height and the same radius, would it be 3 times the volume of the cone? And that answer is always true. And you'll remember we saw the demonstration with the woman pouring the water of 3 cones into the cylinder. Okay, to go to the pyramid, you're going to notice kind of a similarity here. We're going to find the area of the base, but this time the base isn't a circle, it's a rectangle. We're going to multiply it by the height, so just like we did up here, and we're going to divide it by 3, just like we did there. So it's the base area times the height, divided by 3. By the way, dividing by 3 and multiplying by 1/3 are the same math operation. So here is our formula. We're going to take the 1.9 times the 2.4, that's your base area. We're going to multiply it by 2.3, that's your height. If you stopped there, you'd have a rectangular prism, but you're going to divide it by 3 to get the pyramid, and it should be about 3.5 inches cubed. So that was just kind of a quick review, but today we're going to add our last shape. I should say shapes, because we will add 2, but it's going to be the volume of sphere. So everything today is basically going to be like a basketball or a bowling ball or something like that. So a sphere is a set of all points in space that are a given distance, known as the radius, from a given point in all directions. So if you were to put a pin in the center here and swing this radius forward and backwards and left and right and up and down, you would make a sphere. The volume formula is right here, and I've listed it twice. I've listed it the way the book gives it, and then I'm going to list it the way that it's easier to put in the calculator. But the volume of a sphere is 4/3 pi. And notice that the radius is cubed this time. There are your 3 dimensions. Unlike a cone or a cylinder, it doesn't have a height. In our cone and our cylinder, we get our 3 dimensions by having a height and the radius squared. So height, radius, radius. In a sphere, there is no height to the ball. It's just the radius going in all 3 directions. So it's 4/3 pi radius to the 3rd power. And you can probably already guess that that's the number 1 mistake, is people putting a 2 here. The easier way to look at it is to take your radius cubed times 4, divide it by 3, and then multiply by pi. So you'll kind of see right here's the calculator. Take your radius, hit your exponent button to the 3rd power, multiply it by 4, divide it by 3, and if you stopped right there and hit enter, that would be your exact answer times pi. And then if you pick up your calculator again and multiply that by pi, that would be your approximate answer. So let's do some examples. So if you had your book, you see this one, but I've done it out for you. So notice that it is a sphere and its radius is 6 millimeters. So it's 4/3 pi, and the radius will leave and the 6 will substitute in. Now when I'm going to the calculator, if you look down the bottom here, you're going to take that radius, hit your exponent button, so 6 raised to the 3rd power, and then to get the 4/3, it's times 4 divided by 3. If you hit equals, you'd see 288 in the calculator. You haven't multiplied by pi yet, you haven't rounded, that is your exact answer. Now when you take the 288 and multiply it by pi, it's about 904.8 millimeters cubed. Here's another example done in words, and you'll notice as I read, as a reading strategy, I kind of box in or circle or whatever you want to do, underline, so I kind of know what I'm working with as I read. So a spherical stone in the courtyard of the National Museum of Costa Rica has a diameter of about 8 feet. Find the volume of the spherical stone. And again, we have to kind of look here and remember that we're not looking for a cone, we're not looking for a cylinder, we're looking for a sphere. So we're looking for volume equals 4/3 pi r cubed to the 3rd power, right? So the r leaves, and the radius, not 8, but half of that, the radius of 4 takes its place. If you kind of look down here, you can see this is the easier way kind of to set it up for the calculator. There is the 4, the pi, and the radius cubed, and we're going to divide it by 3. So in the calculator, you would take your radius, raise it to the 3rd power, doing this, multiplying it by the 4, and divide it by 3. And if you stop right there, hit enter, you'd see 85.333333 in the calculator. So if you write 85.3 with the bar over it, that's actually an exact answer times pi. That's the answer you'd want to give to an engineer or an architect. You wouldn't want to approximate. You want somebody that is going to be building or doing to use as many digits of pi as possible. Once you do multiply that 85.333333 times pi, you should see about 268.1. Remember, we're going to round to the 10th. That's 1 decimal place. See, the 10th. And the 10th place is the first spot. And our units, in this case, would be feet. And since it's volume, it's to the 3rd. So about 268.1 feet cubed. This is your opportunity to give it a shot. So I'd ask you to pause the video and find the volume of each of these spheres. And when you are all set, press play, and we'll see how you did. Okay, part A has a diameter of 22. So when I go to set up my formula, I didn't put the 22 in for the radius. I cut it in half to put in the radius of 11. In the calculator, I'm going to take 11 to the 3rd power times 4, divide it by 3, and I'm going to hit enter. And when I do, I'm going to see 1774.66666, and at the very end of the calculator you'll notice a 7 because the calculator has run out of room and is rounding. But the exact answer would be 1774.6 with the bar notation times pi. Now times it by pi, and you'll see that the volume of this sphere is about 5,575.3 centimeters cubed. Again, I'm going to warn you that the number one mistake here would be to square it, and the other mistake would be to put the 22 in, which is the diameter, not the radius. Speaking of the radius, this problem gave it to us. So when we go out to set up our sphere formula, it's 4/3 pi times the radius cubed. And this time we can just directly substitute the 5 in because it is the radius. It's only halfway across the center of the sphere. We're going to take the 5 in the calculator and raise it to the third power. We're going to multiply by 4, divide it by 3, and if you hit enter, that's your exact answer times pi. So you'll see 166.66666, and again at the end you'd see a 7 because it's rounding. 166.6 with the bar notation pi is your exact answer. And the minute you take that multiplied by pi, it's about 523.6 millimeters cubed. So that's how you find the volume of a sphere. Now you notice I mentioned two shapes. So in a second, once we finish our vanilla ice cream scoop, what could be better than that? We'll talk about that second shape. See how you do with this one. And pause the video and I'll be right back. Okay, they gave us a radius that makes us happy. So our volume is 4/3 times pi times that radius of 1.2 to the third power. In the calculator, 1.2 cubed times 4, divide it by 3 and hit enter, and you will see 2.304. Now multiply it by pi, and it's about 7.2 inches cubed. Don't forget your units, and don't forget your exponent. Now, a few of you have sent me work, and when I look at the work, it's well, it's kind of meh, to be honest. You really should be showing your substitution, your exact answer, and your approximate answer. You don't have to show this step that I'm kind of tracing over, but there should be 3 steps: your substitution, your exact answer, and your approximate answer. Okay, so let's move on to that second shape, which really isn't that big of a deal. It's a hemisphere, and a hemisphere is half of a sphere. So you'll notice right here that they're putting 1/2, and there's the sphere formula. Well, I kind of think that's kind of crazy. So instead of doing 1/2 of the sphere, what I do is I change my formula, and 1/2 of 4/3, if you think about cross-canceling, this 2 would become a 1, and that 4 would become a 2. Basically, half of 4/3 is 2/3. So in this case, I would take my radius, which is 5, raise it to the third power times 2, not 4, because, whoops, we're doing half of a sphere. We're doing a hemisphere. Divide it by 3. So 5 to the third times 2, divide it by 3, and hit enter, and you'll see 83.33333. And you can write that with the 0.3 with the bar notation times pi. Now take that 83.33333 times the pi button, and the volume of this hemisphere would be about 261.8 feet cubed. Now the other option is to simply find the volume of the sphere, get that answer, and divide it in half at the end. But the danger of that is to forget to take the half at the end. So if you change the formula from 4/3 to 2/3 in the beginning, your answer will automatically be the volume of the hemisphere. Okay, guys, so let's try to see how you do with these hemispheres. Pause the video and see how you do with E and F. And when you're all set, play the video and we'll be ready to see how you did. Okay, let's take a look at E. This hemisphere has a diameter of 2. I know the arrow is pointing to here, but when you see that full red line all the way across in this book, that means that the 2 goes with the diameter. So unfortunately in our hemisphere formula, we need the radius. So we're going to have to cut that in half. So our formula is going to be volume equals 2/3, not 4/3, because remember it's a hemisphere, it's half a sphere, so we took half of the 4. So 2/3 times pi times the radius, half of the 2, cubed. Make sure you cubed it and didn't square it. 1 cubed times 2, divide it by 3, hit equals in the calculator, and you're going to see 0.66666 with a 7 at the end. That's because your calculator's rounding. You're going to write it as 0.6 with the bar notation. Pi, that's an exact answer. And then if you take the 0.6666667 that's in the calculator and multiply it by pi, the volume of this hemisphere is about 2.1 centimeters cubed. When we come over here, we're kind of feeling good because they gave us the radius. So when we go into our hemisphere formula, we don't have to change that 9 because it's already the radius. 2/3 times pi times the radius to the 3rd power. Radius cubed times 2 divided by 3. That's what you're going to do in the calculator. Hit enter, and you should be seeing 486 pi. Multiply it by pi, and the volume of this hemisphere is about 1,526.8. Did you remember your units, meters, and did you put it with the power of 3? So basically, the things to remember when we're working with spheres or hemisphere is to remember that the radius is cubed. There is no height in there, so your 3 dimensions all come from the radius. The hemisphere has a 2/3, and the regular sphere has a 4/3. And that's how you find the volume of a sphere. Thanks for your attention, guys. Have a great day.